Military aviation history is littered with aircraft that should have changed everything. Let's look at 4 aircraft that prove that in the defense world, being super cool and totally awesome doesn't always mean winning. The 5th one that was just dumb and did not deserve a contract. Let's start with the aircraft that probably keeps Northrop engineers awake at night, the YF-23 Black Widow II. Picture this. It's the late 1980s, the Cold War is still chilly, and the Air Force wants a stealth fighter that can sneak into Soviet airspace and ruin everyone's day. 2 teams step up to the plate. Lockheed with their angular, faceted YF-22, and Northrop with what can only be described as an alien spacecraft that somehow learned to fly. The YF-23 was everything the F-22 wanted to be when it grew up. It was fast. We're talking super cruise capabilities that made the competition look like they were flying through molasses. It was stealthier too, with a radar cross-section so small that even if radar could find it, the operator would be wondering why a mosquito was flying around at 40,000 feet. And let's be honest here, it was an absolute beauty. Those diamond-shaped wings, that sleek fuselage, the way it seemed to slice through the air like a hot knife through butter. This thing looked like it was designed by aliens and built by angels. The Black Widow II incorporated some seriously advanced technology. Its engines were buried deep within the fuselage with exhaust nozzles that mixed hot jet exhaust with cool ambient air to reduce infrared signature. The entire aircraft was a study in stealth geometry, with every surface angled to deflect radar waves away from their source. During test flights, it consistently demonstrated superior stealth characteristics and higher supercruise speeds than its Lockheed competitor. So why are we flying F-22s instead of YF-23s today? Well, it looks ugly. Maybe not ugly, just a bit off-putting. Like your girlfriend's birthday makeup. Lockheed had something Northrop didn't, a track record of delivering stealth aircraft on time and on budget with the F-117 Nighthawk. They also had better relationships with Air Force brass, and a more convincing story about how they'd manage the program. Northrop, meanwhile, was dealing with the fallout from cost overruns on the B-2 Spirit program, which had turned into a public relations nightmare. The final nail in the coffin was demonstration requirements. The Air Force wanted to see certain capabilities proven, and Lockheed's YF-22 was more willing to perform the required dog and pony show. Northrop took a more conservative approach to testing, which in hindsight probably looked like they weren't confident in their design. Sometimes in the defense industry, perception matters more than performance, and the YF-23 became a victim of corporate politics and timing. Now let's hop from jets to rotorcraft with the Lockheed AH-56 Cheyenne. This wasn't your grandfather's helicopter. This was what happened when Lockheed's Skunk Works decided to reinvent rotary wing aviation from the ground up. You may notice it doesn't look like a normal helicopter. It has more spinnies. The Cheyenne was designed in the mid-1960s when the Army realized that strapping rockets to transport helicopters and hoping for the best wasn't exactly a long-term strategy. They wanted a dedicated attack helicopter that could provide close air support and survive in a hostile environment. Lockheed's response was essentially to build a helicopter that identified as a fixed-wing aircraft. The Cheyenne was designed to hit speeds of 240 miles per hour, absolutely bonkers fast for a helicopter in that era, though it fell short of this goal in testing. Most conventional helicopters topped out around 150 miles per hour, so the Cheyenne was still the sports car of the rotorcraft world. It achieved this through a rigid rotor system that eliminated the complexity of traditional helicopter rotor heads, and a compound design that used both the rotor for lift and the pusher prop for forward thrust. That's right, a third spinny. The weapon systems were equally impressive. The Cheyenne packed a belly-mounted turret with a 30mm cannon, stub wings for rockets and missiles, and enough firepower to ruin anyone's day from several miles away. The pilot sat in front with an excellent view of the battlefield, while the gunner in back controlled the weapon systems through an advanced fire control system that was decades ahead of its contemporaries. But here's where things went sideways, literally. The rigid rotor system that made the Cheyenne so fast also made it as unstable as a drunk penguin on roller skates. During testing, the aircraft developed a nasty habit of entering uncontrollable oscillations that would build up until the whole machine was shaking itself apart. Test pilots reported that these vibrations were so severe they couldn't read their instruments or maintain control. The technical challenges kept mounting. The pusher prop created complex aerodynamic interactions with the rotor system that engineers couldn't fully predict or control. Test pilots reported problems with directional control during sideways flight, and the aircraft suffered from unresolved technical problems that Lockheed couldn't solve despite years of development. Meanwhile, Bell had already developed the much simpler AH-1 Cobra, which took the tried-and-true approach of putting weapons on a conventional helicopter design. The Cobra had first flown in 1965 and was already being delivered to Army units by 1967, the same year the Cheyenne made its maiden flight. The Cobra wasn't as fast or as heavily armed as the Cheyenne promised to be, but it worked, it was reliable, and it was saving soldiers' lives in Vietnam while the Cheyenne was still trying to solve its fundamental design problems. Okay, now we're climbing way up to the stratosphere with the XB-70 Valkyrie, a bomber so extreme it makes modern military aircraft look like paper airplanes. This wasn't just an airplane. This was what happened when 1950s aerospace engineers were given unlimited coffee, unlimited budget, and told to build something that could nuke Moscow before the Soviets finished their morning vodka. The XB-70 was designed to cruise at Mach 3, that's 3 times the speed of sound, at altitudes above 70,000 feet. To put that in perspective, the SR-71 Blackbird, which is famous for being ridiculously fast, cruised at roughly the same speed but at lower altitudes. The Valkyrie was bigger, heavier, and designed to carry nuclear weapons while maintaining those insane performance numbers. The engineering required to make this work was absolutely bonkers. The entire aircraft was essentially a flying heat sink, with a titanium and steel construction that could withstand the thermal stress of sustained Mach 3 flight. 6 General Electric J93 turbojet engines provided 187,000 pounds of total thrust, enough to power a small city. The distinctive delta wing design wasn't just for looks. It was carefully engineered to ride its own shockwave, essentially surfing on compressed air for improved efficiency at supersonic speeds. The wings could actually fold downward during high-speed flight, creating a compression chamber underneath the aircraft that improved lift and stability. This gave the Valkyrie an almost sci-fi appearance, like it was constantly transforming itself to adapt to flight conditions. The cockpit was pressurized and air-conditioned, because at 70,000 feet, the outside environment was basically space. The sky above was black, and without environmental systems, the crew would have about 15 seconds of useful consciousness. During test flights, the XB-70 proved it could do everything the designers promised. It routinely flew at Mach 3, reached altitudes above 74,000 feet, and demonstrated the kind of performance that made Soviet air defense planners seriously reconsider their career choices. The plan was simple: fly so high and so fast that enemy interceptors and surface-to-air missiles couldn't touch it, drop nuclear weapons on target, and be home in time for dinner. But then reality came knocking with a very large hammer. First, intercontinental ballistic missiles became practical, offering a much cheaper and more reliable way to deliver nuclear weapons across continents. Why spend billions on a complex bomber when you could just launch a missile and achieve the same result? Second, Soviet surface-to-air missile technology was advancing rapidly, particularly the SA-2 system that could reach altitudes previously considered safe for high-altitude bombers. The final blow came on June 8, 1966, during a formation flight intended for publicity photos. The XB-70 was flying alongside several other aircraft when a Lockheed F-104 starfighter, piloted by NASA Chief Test Pilot Joe Walker, got caught in the bomber's wingtip vortex and collided with the aircraft. The F-104 exploded instantly, killing Walker, and the collision sheared off both of the XB-70's vertical stabilizers. The massive bomber continued flying straight and level for 16 seconds before rolling inverted and crashing, killing co-pilot Major Carl Cross, while pilot Alvin White was able to eject but was severely injured. That crash effectively ended the program. Only 2 XB-70s were ever built, and the surviving aircraft was retired to the National Museum of the United States Air Force, where visitors can still marvel at what might have been the most extreme bomber ever conceived. Next up is the RAH-66 Comanche, a helicopter that looked like, well, just look at it. It looks wicked cool. This was Boeing and Sikorsky's attempt to create the world's first stealth helicopter, and for a while it looked like they might actually pull it off. The Comanche program started in the 1980s when the Army decided they needed a reconnaissance and light attack helicopter that could operate in contested airspace without getting shot down by every surface-to-air missile system in the neighborhood. The solution was to apply stealth technology, which had proven successful with fixed-wing aircraft, to rotorcraft for the first time. The result looked like no helicopter that had ever flown before. The Comanche had a sleek, faceted design that minimized radar cross-section, internal weapons bays to avoid external pylons that would compromise stealth, and a finestron tail rotor enclosed within the tail structure to reduce noise and radar signature. The landing gear retracted completely to maintain clean lines, and the entire aircraft was designed from the ground up to be as invisible as possible to enemy sensors. But stealth wasn't the only trick up the Comanche's sleeve. It was designed with fly-by-wire flight controls that made it incredibly maneuverable. Test pilots reported that it could perform aerobatic maneuvers that would make a fighter pilot jealous. The cockpit featured advanced digital displays and sensors that gave the crew unprecedented situational awareness. It could carry Hellfire missiles, Hydra rockets, and a 20mm cannon, all while maintaining its stealth characteristics. The Comanche could cruise at 175 miles per hour and had a combat radius of over 150 miles, making it faster and longer range than most attack helicopters of its generation. Its advanced sensors could detect and engage targets at ranges that conventional helicopters could only dream of, and its stealth characteristics meant it could operate in airspace where other aircraft would be sitting ducks. So what went wrong for the Comanche? September 11th, the terrorist attacks fundamentally changed military priorities, shifting focus from preparing for conventional warfare against nation-states to counterinsurgency operations in Iraq and Afghanistan. Suddenly, the military needed aircraft that could provide close support to troops fighting guerrillas and insurgents, not stealth helicopters designed to penetrate sophisticated air defense systems. The Comanche's advanced technology and stealth features were overkill for fighting enemies who didn't have radar-guided surface-to-air missiles. Its weapons payload was actually smaller than conventional attack helicopters because of the internal storage requirements for maintaining stealth. In the new operational environment, the Army decided they'd rather have more proven Apache helicopters and unmanned aerial vehicles than a smaller number of expensive stealth helicopters. When the program was canceled in 2004, the Army had already spent over $8 billion and was looking at total program costs approaching $40 billion. Military leadership decided that money would be better spent on upgrading existing helicopter fleets and developing unmanned systems that could perform reconnaissance missions without risking crew members. Finally, we come to what might be the most aesthetically challenged aircraft in military history, the Boeing X-32, affectionately known as the Flying Codpiece, for reasons that become immediately obvious when you see a photo. This was Boeing's entry in the Joint Strike Fighter competition, going head-to-head with Lockheed's X-35 to become what we now know as the F-35 Lightning II. Honestly, it's hard to even care about whether or not it could outperform the F-35. It just looks so stupid. The X-32 was Boeing's attempt to create a multi-role fighter that could serve the Air Force, Navy, and Marines with minimal modifications. Boeing's solution featured that massive intake underneath the nose, which looked like the aircraft had developed some kind of industrial-sized overbite. This design was intended to provide sufficient airflow during vertical landing operations, but the result was an aircraft that looked like it was perpetually surprised. During flight testing, the X-32 demonstrated some impressive capabilities and could reach supersonic speeds. However, its hovering performance was underwhelming compared to the X-35's lift fan system. During vertical flight demonstrations, the Boeing aircraft struggled with stability and control, requiring constant pilot input to maintain position. More importantly, the X-32 had what can only be described as a face that only a mother could love. In an era when military aircraft were expected to look fast and aggressive, the X-32 looked like it had been designed by committee. The massive intake gave it a goofy, almost cartoonish appearance that was hard to take seriously. The final blow came when Boeing had to admit that their single design-fits-all approach wasn't actually working. To meet all the performance requirements, they would need to make significant modifications to each variant, essentially creating 3 different aircraft instead of one flexible design. Lockheed's X-35, meanwhile, looked like what you'd expect from a modern fighter jet and provided superior short takeoff and vertical landing performance. When it came time to choose, the decision makers went with the aircraft that looked the part and performed better. Looking at all these aircraft, there's a pattern that emerges. Each one pushed the boundaries of what was possible with existing technology. Each one offered capabilities that were genuinely superior to their competitors in specific areas. And each one fell victim to factors beyond pure engineering performance, politics, timing, changing requirements, or simply bad luck. These failed programs represent billions of dollars in development costs and thousands of hours of brilliant engineering work, but they weren't complete failures. Many of the technologies developed for these aircraft found their way into later successful programs, and the lessons learned from their failures helped inform better decisions in future competitions. That's your Steel Mallard. Don't forget to like and subscribe so we don't end up in the boneyard like the aircraft we covered.